Essentials of Data Transmission, Module 2, Linear System. Signal. In communication systems, mathematical tools are used to describe signals and noise. Communication signals are represented in waveforms. The properties of these waveforms are DC value, power spectral density, and bandwidth. Digital communication signal waveform is commonly represented by square wave. Linear system characteristic. A system refers to any physical entity that produces an output signal in response to an input signal. The response of a linear system to a number of excitations applied simultaneously is equal to the sum of the responses of the system when each excitation is applied individually. Linear system characteristics. In the time domain, a linear system is usually described in terms of its impulse response. The impulse response of a linear system is the response of the system with initial conditions to a unit impulse or delta function delta t applied to the input of the system at time t equal to 0. If the system is also time invariant, then the shape of the impulse response is the same no matter when the unit impulse is applied to the system. Linear system causality. The essence of causality is that no response can appear at the output of the system before an excitation is applied to its input. For a system operating in real time to be physically realizable, it has to be causal. Frequency response. The frequency response of a linear time invariant system is the ratio of the Fourier transform of the response of the system to the Fourier transform of the excitation applied to the system. Let x of f and h of f and y of f denote the Fourier transform of the excitation x of t, impulse response h of t, and response y of t. Fourier transform shows that capital F equal to capital H of f multiplied by x of f, or h of f equal to y of f divided by x of f. In general, the frequency response h of f, or known as transfer function, is a complex quantity. Bandwidth. Bandwidth is to specify the constancy of the magnitude response absolute h of f of a system. For low-pass system, the bandwidth is defined as the frequency at which the magnitude response absolute value h of f is 1 over square root 2 times its value at zero frequency, or the frequency at which magnitude drops by 3 dB. In a bandpass system, the bandwidth is defined as the range of frequency over which the magnitude response absolute value h of f remains within 1 over square root 2 times or 3 dB its value at the mid-band frequency. The following figures shows what is meant by low-pass system and band-pass system. Distortionless transmission. In communication systems, a distortionless channel is often desired. This implies that the channel output is just proportional to a delayed version of the input as shown in the formula. To have no distortion at the output of a linear time invariant system, the amplitude is flat and the phase response is a linear function of frequency with the following formula. When the first condition is satisfied, there is no amplitude distortion. When the second condition is satisfied, there is no phase distortion. For distortionless transmission, both conditions must be satisfied. Distortion of signals. A data pulse in one time slot can smear into adjacent time slots, causing intersymbol interference, ASI. If the system is nonlinear or time varying, other types of distortion will be produced. As a result, there are new frequency components at the output that are not present at the input. In some communication applications, the new frequencies are actually a desired result and consequently might not be called distortion. Linear modulation. Modulation is a process by means of which one or more parameters of a sinusoidal carrier are varied in accordance to a message signal to facilitate transmission of that signal over a communication channel. The message signal is referred to as the modulating signal. The result of the modulation process is called modulated signal. Modulation is performed in the transmitter. The reverse of modulation for recovery of the original message signal in the receiver is called demodulation. Phase and group delay. Whenever a signal is transmitted through a communication channel, some delay is introduced into the output signal. The delay being measured with respect to the input signal. The channel introduces a constant delay equal to T0 that controls the linear phase response of the channel. There is indeed a delay between the input signal and the received signal. The delay is called the envelope or group delay of the channel. It represents the true signal delay insofar as the information pairing signal is concerned.